Hello students, welcome to the chapter Matrices. In my last video, I discussed about the matrices definition and some examples on that. In this video, I am going to discuss about the types of matrices. Let me see the types of matrices. The first type, row matrix. A matrix is said to be row matrix if it has only one row. That means the matrix consists of only one row but many number of columns. So another way of defining row matrix is a matrix of order 1 cross n is called row matrix. So this is another definition for row matrix in terms of order. For example, let A is equal to matrix 1 2 0. So in this matrix you can see that there's only one row horizontal line and three vertical lines, that is a columns. So therefore order of this matrix is 1 cross 3. Let me take another example. B is equal to matrix 1 minus 2 0 4. So in this matrix again there's only one row and 4 columns, therefore order of the matrix is 1 cross 4. Let me take another one. C is equal to matrix 2 minus 3. So in this matrix there is only one row and 2 columns, therefore order of the matrix is 1 cross 2. And these are the examples for row matrix. So like this we can construct many row matrices taking different columns. Now see the second one, column matrix. A matrix is said to be column matrix if it has only one column. That is, in the matrix, if it is only one column and if it has many number of rows, then it is called as column matrix. So another definition of column matrix, a matrix of order m cross 1 is called column matrix. So in this order you can see that m number of rows and there is only one column, therefore this type of matrix is called column matrix. For example, A is equal to matrix 1 2 3, and here you can see that horizontal line second and this is third. We have 3 rows and there's only one vertical line, therefore order of this matrix is 3 cross 1. So number of rows are 3 and number of columns are only 1. So therefore this type of matrix is called now column matrix. Let me take another example. Let B is equal to matrix 0 7 4 minus 2. So in this matrix there are 4 horizontal lines, that is number of rows are 4 and there is only one vertical line, therefore 4 cross 1 is the order. So another example, matrix minus 2 minus 1. In this matrix there are 2 rows and 1 column, therefore order of the matrix is 2 into 1, that is 2 cross 1, etc. Now go for third type, square matrix. It is defined as a matrix is said to be square matrix if its number of rows and number of columns are equal. So in previous examples you can see that there are different number of rows and different number of columns. So if it is same number of rows and same number of columns, then matrix is called square matrix. Or a matrix of order m cross n is said to be square matrix if m equal to n. If these two are same term, then it is called as a square matrix. For example, A is equal to matrix 1 0 3 4. Now in this matrix there are two horizontal lines and two vertical lines. So therefore order of this matrix is 2 cross 2. Here you can say that number of rows and number of columns are equal. Therefore this matrix is called now square matrix. So let me take another example. B is equal to matrix 5 1 3 2 0 minus 1 1 2 6. So in this matrix there are 3 rows and 3 columns. Therefore order of this matrix is 3 cross 3. Now see some important points on square matrix. The first point, a square matrix of order n cross n, simply we say that a square matrix of order n. That means we use only one number. We are not saying like 2 cross 2 or 3 cross 3. We say that simply a square matrix of order 3 or a square matrix of order 2. Like this we say the order of the square matrix. And second point, if A is equal to Aij is square matrix of order n, then the elements A11, A22, A33 and so on, Ann are called diagonal elements of the square matrix. Okay, so here you can see that in the matrix, general matrix of order n, you know the how to write the elements of the matrix in general. A11, A12, A13 and so on, A1n, A21, A22, A23 and so on, A2n, A31, A32, A33 and so on, A3n and so on. AN1, AN2, AN3 and so on, ANN. So this is general matrix of order n. In this matrix, these black elements are nothing but diagonal elements. That is A11, A22, A33, AN and so on, ANN. These elements are called, that means subscript are equal. So these elements are called as diagonal elements of the square matrix. Here in this example, you can say that 5, 0 and 6, these three elements are diagonal elements of the B matrix. Or, so another way of defining, an element Aij is said to be diagonal element if I is equal to j. That means these two subscript, it should be equal. That is the position like 1 1, 2 2, 3 3 or 4 4. Like that, if subscripts are equal, then the element is called diagonal element of the square matrix. The matrix should be square only. And third point, the other elements are called non-diagonal elements. That means these remaining elements are called in the square matrix are non-diagonal elements. In the above example, this upper side elements, that is 1 3 minus 1, and this lower side 1 2 2 1 2, these elements are called non-diagonal elements. Once again I repeat, these line elements are called diagonal elements, and these side elements are called non-diagonal elements. In this second A matrix, 1 and 4, these are the diagonal elements, and these two numbers are non-diagonal elements. Here you can see that these, whatever the numbers are rotating, these are non-diagonal elements in the square matrix. Next, fourth type, rectangular matrix. A matrix of order m cross n is said to be rectangular matrix if m is not equal to n. That means if these two are different, then the matrix is called rectangular matrix. Or another definition, a matrix is said to be rectangular matrix if it is not square matrix. If it is a not square type, then it is called rectangular matrix. For example, A is equal to matrix 1 0 2 3 4 1. So in this matrix the order is 2 cross 3. Here you can see that the number of rows and columns are different, so therefore this type of matrix is called rectangular matrix. So another example, matrix 5 1 3 0 2 0 minus 1 1 1 2 6 2. So order is 3 cross 4. Now next type, diagonal matrix. A square matrix is said to be diagonal matrix if all its non-diagonal elements are 0. So in the square matrix, you know that we have two types of elements. One is diagonal elements and another is non-diagonal elements. Diagonal elements may be any number, but all non-diagonal elements are 0, then it is called as a diagonal matrix. For example, let A is equal to matrix 1 0 0 4. Here you can see that these non-diagonal elements are in this matrix are 0 number, and diagonal numbers are 1 and 4. So therefore this matrix is now diagonal matrix. So another example, B is equal to, it is of 3 order, 5 0 0 0 minus 1 0 0 0 2. So in this example, the diagonal numbers are 5 minus 1 2, and non-diagonal elements are, you can see that all are 0. So therefore this type of matrices are called diagonal matrices or diagonal matrix. Next type, scalar matrix. A diagonal matrix is said to be scalar matrix if its diagonal elements are equal. Here you can see that students, in the definition only the term used diagonal matrix. That means already you know that it is which type of matrices. Diagonal numbers are there, but non-diagonal elements are 0. But for that one more condition is there, diagonal number should be same. If diagonal numbers are same numbers, then the matrix is called scalar matrix. So another way of defining scalar matrix, a square matrix is said to be scalar matrix if all its non-diagonal elements are 0 and diagonal elements are equal. Okay, in terms of a square matrix, then you have to define both elements, diagonal and non-diagonal elements you have to define. Like non-diagonal element should be 0 and diagonal elements are equal. For example, A is equal to matrix, a square matrix of order 2 2 0 0 2. So in this example, you can see that the diagonal numbers are 2 and 2. They are same numbers, and non-diagonal numbers are 0. So therefore this matrix now it is called scalar matrix. So another example, B is equal to a matrix of order 3 cross 3, and the elements are minus 3, 0, 0, 0, minus 3, 0, 0, 0, minus 3. In this example, the diagonal elements are minus 3. All numbers are same, and non-diagonal elements are 0. So therefore this is of the type scalar matrix. Or a square matrix aij. So this is another way of defining scalar matrix. A square matrix aij is said to be scalar matrix if aij is equal to 0, I not equal to j, and aij is equal to some k number when I is equal to j. See, diagonal numbers are means subscript should be same number, like 1 1 2 2. If I is equal to 1, if I take, then j should be 1, a11 it should be some number k. In the same way, if I take I equal to 2, if j is equal to 2 position, that is 2 2 position, the it number should be same k only. It is not different. If it is a different I and j, for example I equal to 1, j equal to 2, that is a position a12, then element value is taken as a 0. So that means non-diagonal elements become 0 number and diagonal elements become a same number. Then you will get this type of matrix. That is a scalar matrix for some constant k. Now see the next type, identity matrix. A scalar matrix is said to be identity matrix if its diagonal elements are equal to 1. Now already you know the scalar matrix meaning. In that scalar matrix, the diagonal numbers are equal, but the number is equal to 1, then matrix is called identity matrix. So another way of defining identity matrix is a square matrix in which elements in the diagonal are 1 and rest all are 0 is called an identity matrix. So another definition, a square matrix aij is said to be identity matrix if aij is equal to 0 when I not equal to j. That means the position elements like 1 2 1 3 2 1 2 3 3 1 3 2, in that the subscripts are different, then the value of the element is 0. Okay, and aij is equal to 1 when I equal to 0. When aij equal to 1 when I equal to j. That means when subscripts are like 1 1 2 2 3 3, then element is taken as 1. Remember, the identity matrix of order n is denoted by in or I. For example, I is equal to a matrix, a square matrix of order 2 1 0 0 1. So this matrix is called now identity matrix because the diagonal elements are 1 and non-diagonal elements are 0, or it is a scalar type in which the scalar diagonal elements are equal to 1. So therefore this is identity matrix, and this identity matrix we denoted by either I or I2. Order is mentioned. Okay, I2. Now another different order identity matrix, I is equal to square matrix of order 3 1 0 0 0 1 0 0 0 1. In this matrix the diagonal numbers are 1 and remaining all elements are 0. That means this matrix is called identity matrix of order 3. Are identity matrices of order 2 and 3 respectively. So next type, zero matrix. A matrix is said to be zero matrix if all its elements are 0. If I take all elements 0 in the matrix of any type, it may be square type, or it may be rectangular type, or it may be scalar type, or it may be any type of matrix. If all numbers are 0, all elements are 0, then matrix is called zero matrix. For example, here in this example you can see that matrix 0 0 0, all numbers are 0 taken, therefore this is zero matrix. So this is another type, zero matrix. So all these matrices are zero matrices. So remember here some points. Zero matrix is denoted by O, capital letter O. That means we denote A, B, C, D, no, like that. We denote this zero matrix by O. Second point, zero matrix is also called as null matrix or void matrix. Next definition, equality of matrices. Two matrices, A is equal to Aij and B is equal to matrix Bij, are said to be equal if the first condition, they are of same order. Second point, each element of A is equal to corresponding element of B. That is, Aij is equal to Bij for all I and j. That means in the A matrix, the first position element, and in the B matrix, first position element, both should be same. Like that, remaining all position elements of A, it should be same as B matrix. For example, let me take A matrix is equal to 2 1 0 1 0 5, and B matrix is equal to 2 1 0 1 0 5. Here A and B are equal matrices, because position wise you see in the A matrix the first element is 2, and in the B also we have 2, and second position 1, here also in the B matrix 1. In A matrix third A1 3, that is 0, here also it is 0. So remember students, two matrices A and B are equal, we write A equal to B. I hope you understood whatever I discussed in this video. Thank you.